I take 1 root.
Okay, so we already did an example yesterday, so Jay, we're gonna start with a different example. You think so? Okay, so the example we are starting with is 6 times the square root of x plus 7 times the square root of y minus 3 times the square root of x. So when we are doing radical operations, the first thing we have to check is that our radicals are completely simplified. And if they're not, then we need to. If they are completely simplified, we look for terms that have the same value under the radical. And then I can put those together as if they were like terms. So obviously I have no simplification happening in this expression. Do I have any like terms in this expression? Yes, Pfeiffer, which one are ones?
6, 7.
Say that again.
6, 7.
Okay, so I can't count the whole numbers of like terms. It has to be the whole part of it. The x and the x. So 6 root x and negative 3 root x are like terms because what's under the radical is the same. So I put those together with the operations in front of them. So this is positive 6 and negative 3. 6 minus 3 is 3. So those together is 3 root x, and then I still have to have the plus 7 root y. So my simplified expression here is 3 times the square root of x plus 7 times the square root of y.
Oh, that's it.
That's it. How do we feel about that?
Ain't so bad.
5? Okay. We are going to do some more, of course. What?
I thought it was going to be in square root.
Oh.
No. You
We can't put them together like that.
Yeah.
If I was multiplying, we could theoretically, but not adding. Okay, so next example is going to be, oh, I don't know, let's do this one. Negative 3 times the square root of 3 plus 3 times the square root of 27 minus 2 times the square root of 12. We have to simplify first. Oh, okay, so I have to pull out those first before I can simplify. I'll show you in a second. Yes, ma'am. After this example, yes. Okay, so as I'm looking at this right now, there's nothing I can put together, but I also recognize that this term and this term are not simplified under my radical, right? Each of those two has a perfect square still in there. So what I need to do is I need to simplify each of those, and then I can see if I can combine any like terms. So I'm going to factor tree these. What multiplies together to get 27? 9 and 3. Technically, I can stop here because 3 is prime and 9 is a perfect square, right? What about 12? What multiplies together to get 12? 4 and 3. Again, I can stop here because 3 is prime and 4 is a perfect square. So what I'm going to do is I'm going to rewrite this with that multiplication under the radical. And then we're going to pull out those perfect squares. So 9 here's a perfect square, and I know that its square root is 3. So that means I'm going to multiply a 3 out here with the 3 that's already there. 4 is a perfect square, its square root is 2. So I'm going to multiply a 2 out there in front. This then becomes negative 3 root 3 plus 9 root 3 minus 4 root 3. So all I did was simplify these by pulling out perfect squares, and I multiplied their roots into the numbers that were already there. Now I notice that all 3 of my terms are the same. They all have a 3 under the radical. Yes, my friend. That's fine.
So would I just do it the other way? Pull out the set?
Pull out the substitute and put them out. Yep, same concept. Since they all have just a 3 under the square root, I can put them all together by adding or subtracting the numbers in front of those square roots. So I'm going to take -3 plus 9 minus 4. -3 plus 9 is 6, minus 4 is 2. And all of my terms had a square root of 3 on them, so my answer has to as well. And then you're done. How do we feel about that one? Pretty good? So?
How many more examples?
We'll probably do like 5 more.
Well, that's just fine.
That's really not that many.
Just gonna say like.
Yeah, quickly.
Can we just do it?
6, okay. We will see. Okay, are we ready for the next one? Yes, no, maybe so? Okay, next one.
Okay.
-2 times the square root of 24 minus the square root of 54 minus 3 times the square root of 5. Is there anything I can put together right now the way it is? No, which means I need to simplify these. Will I simplify all 3 of these or just 2 of them?
Just 2.
Just 2 because this one cannot be simplified anymore because 5 is already primed. So what I need to do is I need to factor tree the 24 and the 54. When I factor tree the 24, what multiplies together to get 24? 8 and 3, perfect. 3 is prime, 8 is not. It's also not square. So I can break 8 down farther into 4 and 2. 2 is prime, 4 is not. 4 breaks down into 2 and 2. Do the same thing with the 54. What multiplies together to get 54? 9 and 6. You could stop at 9. I'm going to keep going just in case you don't recognize that it's a perfect square. And 9 breaks down into 3 and 3. So now what I'm going to do is rewrite these radicals with that prime factorization happening. Yes, ma'am. No, 6 is 2 and 3. Oh, yeah, sorry. We would have to break that out. I apologize. Now I'm going to go ahead and do my prime factorization. So this becomes -2 times the square root of, I have 3 2's and a 3, minus the square root of 1, 2, and 3 3's. And then minus 3 root 5. Right? So I'm showing you another way of doing this. Now I need to simplify what's under the radical, so I'm looking for identical pairs of how many numbers? 2, because it's a square root. I have one set of 2's here, so a 2 is going to come out, and it's going to become -4, square root of what's left, which is 6. Do I have any identical pairs in the second radical?
Yes.
Yes, I have what?
3, 2,
1 group of 3's, right? So a 3 is going to come outside. And this is going to become 3 times the square root of 6, because 2 times 3, which is left, which is 6. And then minus 3 root 5. They are simplified, so now I combine like terms. Do I have any like terms here?
Yes.
Yes. The 2 root 6 terms. So how do I combine them? Perfect. And we also have to bring in the term that was not able to be combined with anything. So my final answer is -7 root 6 minus 3 root 5.
Okay. Yeah.
I'm going to give you a second to pause and look through this one to make sure that it makes sense before we move on to the next one.
So you only combine 2 terms.
To here, we only combined 2 terms because only 2 of them.
When it was 2 times 2 times 3, you only combined the 2.
Yeah, because I was looking for groups of 2, and I only had 1 group of 2 here.
Oh, yeah, because of the number.
Yep. Yep. Hey, shh.
Yeah, baby. So,
Hi.
so if we discuss operator. Or is it just the same thing?
Just for groups of 5, yeah. However, on the homework, I did not give you anything above the square root.
So then
Correct. I do not believe I did.
Oh,
Okay, let's do another one. So I have the square root of 5 times 2 times the square root of 15. When we multiply two radicals together, we do it in 2 steps. Step 1 is to multiply the coefficients or the numbers in front of the radicals together. When there's nothing in front of the radical, we assume it's a 1. So I do 2 times 1 to get 2. Step 2 is to multiply the numbers under the radical together and put their product under the radical again. So 5 times 15 is 75. So this becomes 2 times the square root of 75. And now I'm ready to simplify this. How am I going to simplify the square root of 75? Factor tree. What multiplies together to get 75? 5 and 15, obviously, we just did it. 5 is prime, 15 is not. What multiplies together to get 15? 5 and 3. So what I'm left with is 2 times the square root of 5 times 5 times 3. I'm looking for groups of how many, Grant?
2. Oh, sorry.
You're okay. 2. How did you know that, Grant?
Square root.
Because it's a square root. Do I have any groups of 2 identical numbers?
Yeah.
Yes, the 5s, which means I'm going to pull a 5 out and multiply it into the 2 that's already there. And I'm going to leave the 3 under. So this becomes 10 times the square root of 3. How did we feel about that one? Pretty good? Coefficients first, and then what's under the radical. I'm going to have you do one of these on your own in just a second, and then we'll move on to the next part. Okay. The one for you to do on your own. Is this one. Think you did it right? Hannah, talk me through it.
Have to assume that there's 1.
Perfect.
There, so you multiply 2 and 1. Get 2.
Tell me what we did next. Yeah, we should multiply those together, and that becomes a 9 under the radical.
Then you break that.
Then we break it down. Do I have to factor tree that one?
No.
You could if that worked for you, but I know automatically that the square root of 9 is what? 3. So that means that's going to multiply a 3 outside. So then I'm going to have 2 times 3, which is just equal to 6. When we're multiplying, we multiply everything. Okay, please do not forget to do that. Are we ready for the next one? Yes. Of course we are. This problem is 4 times the square root of 8b cubed times the square root of 6b. It's going to work the exact same way as the ones we just did. So what is going to be my first step, Carly?
To multiply
And that's gonna give me what? Awesome. And then Heath, what will I do next?
Oh, you would multiply the
8 and 6 to get what? 48. And then what else would I multiply together, Heath?
the b's.
The b's. So I'm gonna have b cubed times b, and that's gonna give me what?
B to the fourth.
B to the 4th, because we add the exponents. So this multiplied together becomes 4 times the square root of 48b to the 4th. Are we okay with that? Then from here, it's just reducing this by factor treeing and then breaking the variable down. So we're gonna start with a factor tree. What multiplies together to get 48, Ariana? 8 and 6, super easy. Neither of those are prime, so they both break down. 6 breaks down into 2 and 3. 8 breaks down into 4 and 2. And then 4 breaks down into 2 and 2. At the same time, I'm also going to do my variables once I factor tree this out. So this becomes 4 times the square root of, I had 4 2s and 1 3. And then I also have 4 b's that I'm going to write down.
That's a lot of b's.
It is.
Hopefully you're not allergic.
And then in all of this, to take it out in front of the radical, I'm looking for groupings of how many? 2 identical numbers. The 4 is a coefficient, not a root value. Okay, so make sure you know the difference. So we are looking for a square root, which means groups of 2. We're going to start with numbers. Do I have any groups of 2 identical numbers?
Yes. Yes.
Yes, I have 2. I have 2 sets of 2, which means each of these is going to pull a 2 out front. And that's going to go away. The 3 can't group with anything. Can't group with anything, so it's going to stay. Do I have any groups of B that are going to come out front?
Yes.
Yes, how many? 2. Each group of B is going to pull a B out of here and put it out front. So now what I'm left with is 4 times 2 times 2 times B out front. And all of that times the square root of 3. And we just simplify this. 4 times 2 is 16. B times B is B squared. And then the square root of 3. Does that make sense? Yes.
It's always 2.
For square root? Yes. Yes. And I do believe on the homework I gave you nothing larger than a square root. And in the notes we don't have anything either, so we're pretty much just working with square roots here. You're gonna have a quiz next week. Okay, we're gonna do 2 more examples and we're done. Are you guys ready? Yes, okay. Anybody have an idea of how we're going to do this? Okay, so what we're going to do is we're going to take this entire first term and we are going to multiply it into both of the terms inside my parentheses. In other words, I'm going to distribute that first term to the parentheses terms. When I distribute it, we multiply the coefficients together and we multiply the radicals together. No, like everything. Yeah, okay. So we're gonna start with 5 times the square root of 5b times 10, or square root of 10, sorry. I multiply the coefficients together first. This is 5, that's a 1. 5 times 1 is 5. Then I multiply what's under the radicals, so 5b times 10 becomes 50b. Then plus, I'm gonna do the same thing. I'm gonna multiply this first term to the 3. There's no radical there, so I'm just multiplying the coefficients together. 3 times 5 is 15, and the radical 5b is gonna stay the same. That's what I mean when I say distribute it in. And then from here, we reduce like normal. So we'll factor tree, we'll break the variables down, and we're gonna look for groups of 2 identical terms. Yes,
Are we gonna do, oh, no.
we're gonna start with the 50. What does 50 break down into? 5 and 10. 10 breaks down into 2 and 5. 5 is prime, so it's not gonna break down at all, and each of my b's are singular, so I can't do anything with those. So I'm just gonna rewrite this as 5 times 2 times 5 times 5 times b plus 15 times 5, or square root of 5b, sorry. And then we're gonna pull out identical pairs. Do I have any identical pairs here? Yes, where? The set of 5s right here, which means when I pull it out, I'm pulling out one singular 5, which makes out front become 25 times the square root of what's left, which is 2b, plus 15 times the square root of 5b. And then we just look to see if we can put anything together. Can we? No, because I don't have identical radical values, so this is it. How do we feel about that one? Really, truly, how do we feel? Okay-ish? Ish? Maybe.
It's tolerable.
Okay, we're gonna do one more and then we're done for the day. And by for the day, I mean with the lesson. I'm actually gonna let you guys work through this one on your own first, and then we will come together and go over it as a class.
Oh, okay, I think.
Okay, so the first thing I did is I distributed 4 times the square root of 5m to both the root 2m and the root 3m that were in the parentheses. When I did, I got 4 times the square root of 10m squared plus 4 times the square root of 15m squared. Everybody okay so far? Fantastic. So now what I want to do is I want to reduce the values that are under the radical as well as the variables to see if I can pull out any identical pairs. So the only thing that multiplies together to get 10 is 2 and 5. And then 15 would be 3 and 5. The m I know is, or m squared is going to break up into m times m. So this becomes 4 times the square root of 2 times 5 times m plus 4 times the square root of 3 times 5 times m. Then I'm going to look for identical pairs. In my first radical, the only identical pair I have are the m's. So I go ahead and pull a base m out. So the first radical becomes 4m times the square root of 2 times 5, which is 10. Same thing happens in the second radical. I only have an identical m pair. So then I'm left with 4m times the square root of 3 times 5, which is 15. These are reduced and there are no identical radical values, so I am finished. How many of you got this answer working on your own, just out of curiosity? Okay. Any major issues with anything that we have done today? Okay, your homework is on Canvas and it is due tomorrow. If you have questions, please, please, please let me know.